So today we're doing section 10-2, tangents of circles. And we're talking about all the parts of the tangent. We're not just talking about tangent lines. We're talking about tangents, and so we're doing tangent lines and their parts. Okay, so what is a tangent line? A tangent line is a line that is tangent to a circle. So a line tangent to a circle touches the circle at exactly one point at only one point and is perpendicular to the radius at the point of tangency, or at that point. That point is known as the point of tangency. So point of tangency, point of tangency. It's the point where the tangent line touches the circle. Okay, and I'll draw this with labels in a second. A tangent segment is a segment that has the endpoint at the point of tangency Okay, so it's part of the tangent point. So it's endpoint at the point of tangency. And is part of the tangent line. So it has to be on the tangent line, and endpoint touches at the point of tangency. So let's look at a circle here. Okay, we'll have a center of our circle. We'll call it S. We're going to put point Q over here on our circle. Point P is going to be there on our circle, and point T is down here on our circle. Okay. Now I'm going to draw a tangent line at S. Now what I do is I line up 90 degrees perpendicular, so I can go 90 degrees and make sure it touches my S, because that means it's perpendicular to the center at this radius here. 90 degrees, and it only touches at point P, and we label this point A out here. So we have P is called the point of tangency, and PA, that's not a P, PA is my tangent line. Okay. Now, let's talk about the tangent segment. So let's draw another tangent at Q and one at T. Now, tangent segments are usually grouped together with another tangent segment. So tangent segment is going to be perpendicular. So we're going to draw a tangent line perpendicular to Q this way. And I'm going to draw a tangent line perpendicular to ST this way. And they're going to touch out here at this one point, and we're going to call that point R. So this is the point outside the circle where the two tangent lines meet. The tangent segment is QR and TR. These are tangent segments. And the reason tangent segments are usually paired together is because when you have a tangent segment, two tangent segments that share the same point outside the circle, okay, so two tangent segments share the same point outside the circle, have equal distance to that point, so they're congruent segments. Now, this shape makes a kite, as you can see, with a 90-degree angles at that point right there. What really makes this special is that if this is 45 degrees, we can figure out our central angle real easy is 135 degrees because these two are always going to be supplementary, which means the arc QT is always going to be 135, or is always going to be equal to the central angle. So the arc contained by two tangent segments is always going to be the supplementary angle to the angle out at the tangent segments. All right? So so if we have a tangent segment up here too, which is PA is also a tangent segment. Okay? So we have tangent segment QR, tangent segment QT, or RT, and those are shared. They share a point R, so they're congruent. PA is not part of that group, so PA is not congruent to RT. We don't know anything about that. All right. Let's try to do a problem. So there's a couple different types of problems that they have you do with these tangents. So example A is the kind of problem where they have a circle and they have a tangent line drawn, or a tangent segment actually drawn out like this, and they say that AB, we'll call this circle R, they say AB is tangent to circle R, and they make a mark here, and then they make a line segment here. They connect A to B, and they say this point C, and they say they give you maybe one of these, couple of these measurements. They'll give you the radius is say 5, and they'll give you the length of CA equals 8. Measurement CA is 8, so this distance is 8, and they'll say, hey, what is the length of AB? What is the measurement of AB? And so the way we do this is we know that the radius is the same all the way around. So we can say that CR is 5, and our unknown value we'll label as X. Well, the cool thing about knowing that AB is tangent to circle R at point B is that we know this is a 90-degree angle. So this becomes a Pythagorean theorem problem. Our hypotenuse is opposite the 90 degrees, so that's 8 plus 5 is 13. Our short leg is 5 because that's the radius, and then X is our long leg. So X squared plus 5 squared equals 13 squared. X ends up being 12. Measurement at AB is 12. The second time of problem is when we have a circle and they give us a polygon around our circle. And a lot of times it'll be a quadrilateral. Sometimes it'll be a triangle, but a lot of times it'll be a quadrilateral. And they may not give you, they may say, hey, what's the perimeter of A, B, C, D? So what is the perimeter of A, B, C, D polygon? And they might give you this is 3, and this is 2, and this is 4, and this is 5, and they expect you, and they say, hey, all A, B, so this is inscribed circle, they call it, or circumscribed polygon, which means that each one of these sides is a tangent segment, or tangent line. So since they're tangent lines, that means that this is a point of tangency, this is a point of tangency, here, and here. Now, I'm not going to label those because it'll get messy. But I can say that if this B to that point is 3, then I can say B to this point is also 3. So I can label that. Is here at that one. These two are congruent. And these two are congruent. And last but not least, these two are congruent. So this is 5, this is 2, and this one is 4. So we have 5 plus 5, 3 plus 3, 2 plus 2, 4 plus 4, and add them all up, and we get our perimeter. So in this case, we have, what is that? 10 plus, so 3 plus, so 3, plus 3 is 6, plus 6, or plus 4 is 10, plus 10 is 20, plus 28. So our perimeter is 28. All right? 5, 9, 13, 15, 20, 28. Okay? And last, not least, example C is when we have two circles. That is a horrible circle. I'm going to draw these a little bit closer. And this one's a little bit smaller. And they share tangent lines. So we have a line that's tangent to both, two lines that are tangent to both circles. Okay? And they'll have something like AB here, and this point will be C, and this point will be D, and this point will be E, and then they'll have some radius, call this circle R, and call this circle O. Okay? And what it'll say is, hey, what is the length of AC? And they'll give you some values out here. So we'll use this technique from example 1, or example A, and figure out what these measurements are. Now also what's really cool about this is that since that's 90 degrees and this is 90 degrees, this polygon that's in here, this OACR, is actually a trapezoid. So this side is parallel to this side. And so that's another example of how you calculate out. And we know that this segment and this segment are congruent. This segment is congruent to this segment because of the segment addition properties. Because we know that BE is congruent to AE. All right, thank you very much.